This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson. Today's story is about an idea you probably know of, even if you don't know it by name. It's a story that starts in the pelvis and expands to explain just about everything. Sex and childbirth and helpless, big-brained babies, upright walking, and even how societies are shaped. On this episode, we're exploring the obstetrical dilemma.
What is the obstetrical dilemma? Okay, it is this idea that I've been grappling with for 12 years. Oh my goodness. And it's this really elegant human evolutionary hypothesis that I think has been so popular and is so elegant, people don't even realize it's a hypothesis.
This is Dr. Holly Dunsworth. She's a Leakey Foundation grantee and an associate professor of anthropology at the University of Rhode Island.
And what I do is I do a lot of teaching of biological anthropology courses there. And when I'm not doing that, I try to do research in human evolution.
A lot of Holly's research has centered on this idea, the elegant hypothesis called the obstetrical dilemma. It addresses one of the most confounding mysteries of human biology. Why is childbirth such a struggle in humans compared to other primates? Why is a mother's pelvis not bigger compared to the size of our babies? And why do our babies seem so helpless and need so much care? These don't seem like ingredients for a successful species, yet here we are. Answers to all of these questions can be found in the obstetrical dilemma hypothesis.
And it's this idea that selection for bigger and bigger brains meant bigger and bigger brained babies. But selection for bipedalism meant a limit on the size of our birth canal. And so at some point with the increasingly bigger brain over time, we encountered a dilemma, an evolutionary dilemma, the obstetrical dilemma. And how do we solve it? We've solved it, according to this idea, by giving birth early. And that's why babies are so helpless.
The ideas behind the obstetrical dilemma had been around in anthropology for a long time. But it really took off in 1960 when a biological anthropologist named Sherwood Washburn wrote an article in the magazine Scientific American. Washburn was a leading scientist in his field, and he's contributed a lot to our understanding of human evolution and primate behavior. He was even one of the founding scientific advisors of the Leakey Foundation. The article he wrote was called Tools and Human Evolution, and it was a general overview of those two things. It was written for non-scientists. It wasn't even about childbirth or babies. But in the last paragraphs of the article, Washburn wrote this: humans are born underdeveloped. We are born early in order to escape just in time before we outgrow the birth canal. This early birth was caused by antagonistic natural selection. He set up this idea that as humans evolved, there were these two forces of natural selection working against each other. Our brains were getting bigger, but the evolution of bipedalism prevented our birth canals from expanding. So, he says, difficult, dangerous childbirth of underdeveloped, helpless human babies are both evidence of and solutions to this obstetrical dilemma. And that's it. A straightforward, intuitive, evolutionary explanation that addresses a lot of big questions about how we evolved.
I, like a lot of people, have spent a lot of my time thinking about human evolution, really loving this idea and thinking it was a really compelling story, not even using that word story. And by the way, when I use it, when we talk, it's not a derogative word to me. Science is stories. It's okay for me. I just want our listeners to know that too. But I wouldn't have even called it that then. I wouldn't have even thought of it as a story. I would have thought it was set fact. And it was a really compelling way to demonstrate the reality of evolution, of human evolution, to me and to a lot of people.
This idea spread from the pages of Scientific American to anthropology classrooms and textbooks and medical schools and parenting books everywhere. And after a while, it was just accepted as the evolutionary explanation for what we all know to be true about birthing babies.
Yeah, everybody knows childbirth is really hard and difficult, and it doesn't really seem to make sense. When you're first learning about evolution, you're just hit over the head with survival and reproduction. And when you combine that with how difficult childbirth is, you just kind of wonder, like, well, what's going on? It doesn't seem to fit with how I, as a newcomer to thinking evolutionarily, think about evolution. So there must be a reason why childbirth is so hard. And yeah, babies are helpless. What's up with human babies? Some people say they're useless. That's what's going on. And this story explains those two things so well.
Holly first learned about the obstetrical dilemma in college, when she was a teaching assistant in graduate school. She even taught it to her students. She thought of it as undeniable proof of the importance of evolution in our daily lives, and she never heard anyone call it a hypothesis. In her PhD program, she focused on reconstructing childhood growth and development in the fossil record. She did her dissertation on how baby primates' feet can cling to their mothers. After getting her PhD in 2007, she joined Nina Jablonski's lab at Penn State as a postdoc.
It's the most wonderful thing. You just roll out of bed, like with birds chirping, like I go get to learn all day and do science all day and nothing else. It's the best thing in the world, especially with Nina as your mentor. We had some big ideas about life history changes correlated with environmental changes and ecological changes. So I'm in this literature, a lot of which was on paper that she had stacked up in a very organized way. And I'm reading all of these papers that I'm realizing, oh my gosh, I'm in the literature where I'm going to see the evidence for the obstetrical dilemma. I'm going to see how, because life history includes gestation length, fetal growth, brain size, the length of childhood, age of pregnancies, numbers of pregnancies. These are the sorts of variables that go into what we call life history. And I thought, I'm going to find the evidence for the obstetrical dilemma. I didn't even think I wouldn't. I just thought, oh, I'll see it now. This is where I'm going to see it.
As she read the scientific literature, the first evidence she looked for was research supporting the statement that human babies are born early.
And immediately, I see that we don't have short gestation lengths. We don't have short pregnancies. That's what you would expect if our babies are born early, and then that's why they're helpless.
At an average of 40 weeks, humans actually have longer pregnancies than any primate, including our great ape relatives. Our pregnancies are 2 to 3 weeks longer than gorillas and orangutans, and 5 to 6 weeks longer than chimps.
So gorillas, chimps, orangutans have very long pregnancies, almost as long as ours. But we have the longest, and we have maybe longer than you'd expect for a primate of our body size. So we have long and maybe especially long pregnancies. None of that screams that we're birthing our babies early to solve a dilemma. So immediately, my interest is piqued. I am like, this is just so fascinating and exciting to me. That's it. That just started everything for me.
You can imagine why this was so exciting. The connected ideas that make up the obstetrical dilemma touch on so many aspects of what makes us human. Childbirth and development, our extraordinary brains and locomotion, and ideas about women and women's bodies that have shaped our social roles. If this story that's assumed to be true turned out not to be true, that's absolutely huge. That means there are other explanations out there. So Holly set out to investigate every element of the obstetrical dilemma.
I would go to the meetings, I would strategize the conference talks I would listen to and the posters I would visit based on all of the different rabbit holes I had to go down to unpack the obstetrical dilemma, and all the different fields that go into all the assumptions and biases that go into telling this story.
There were 3 connected assumptions in the obstetrical dilemma story that she wanted to unpack. First, that our babies are born early and underdeveloped. Second, that the pelvis can't get any bigger because if it did, women's hips would be too wide to walk well, and walking is key to how we evolved our big brains in the first place. And last but not least, the assumption that because of the competing evolutionary pressures of childbirth and locomotion on the female pelvis, evolution's compromise was a pelvis that's not great for either childbirth or walking. After seeing that our pregnancies are long in comparison to the other apes, she started to look for evidence that our babies are underdeveloped. In biology, animals that are exceptionally helpless and underdeveloped and can't move around for a period of time after they're born are referred to as altricial. Altricial babies need parental care to survive. The opposite of that is called precocial, so a baby that can move around right away and that's born more developed, like a sea turtle, for instance, that hatches and crawls into the sea to fend for itself.
The most well-known altricial mammal is probably a kitten or a puppy. Their eyes aren't even open. They don't have a lot of their fur yet. And they nest or they den. They're parked for a little bit. And they take a while to mature enough to walk on their own. And then the best known precocial mammal is a horse. And primates fall on the precocial side of things.
Chimps cling to their moms and start getting their own food at an early age, even when they're still nursing.
If primates are precocial, but humans are so helpless, how do you explain us? So we've been deemed secondarily altricial, and there's still people who call us altricial. And I don't think altriciality really is a good term to apply to humans, as if we are somehow especially different from the rest of the primates. The more people have learned of these last 70 years of observations of primates in the wild and in captivity is that a lot of primates are born helpless, not just humans. Chimpanzees take a long time as newborns. They take a long time to be able to cling to their mother, to be able to thermoregulate. So do capuchin monkeys, for example, and notably, they're also very big-brained. So if humans didn't exist and we wanted to look at the rest of the primates, you'd still see like some of the biggest brained primates, like chimps and capuchin monkeys, are born relatively helpless.
Like our babies, baby chimpanzees are intensely cared for by their moms until they can cling to her, and they're inactive for large portions of the day.
We don't really stand out in all the ways I think that people assumed we had back in 1950. And I can't help but think that in 1950, when people were talking about this, a lot of the people who were talking about the obstetrical dilemma were people who might not have had a lot of experience with babies themselves. And if you don't, you do tend to think of them as helpless, useless bags of goo. But the more experience you have with baby humans, you realize, wow, they are manipulating me. They are advancing rapidly. They're amazing learners. They're taking everything in. They just are terrible at grasping on me. Now, that's a really fascinating aspect of being human that deserves investigation and that needs its own story. But it doesn't have to be the solution to an obstetrical dilemma. It could be part of a different story, and I think it is.
So this brings us to the underdeveloped brain part of the obstetrical dilemma. And there's no denying that our brains grow and develop for a long time after we're born. If we look at chimps in comparison, scientists say chimps are born with about 40% of their adult brain development already in place, and humans with about 30%. So we need to grow our brains by 70% after we're born.
This is extraordinary about us. We are born with less of our adult brain than a chimp is. So they seem more advanced. And that's long been used as evidence to say we're born too early. Like that we should be born with a greater proportion of our adult brain to match what chimps are born with. That's an arbitrary call. Just because they're born with 40%, we're born with 30%. Like as if we should be born with 40%, but that must mean we're born early. And that, humans should be born with the same percentage of adult brain growth as chimps.
And some scientists have taken that to mean that if it weren't for the need to get babies through our constricted birth canal, human pregnancies should be way longer than they already are. More like 20 months instead of 9 months.
But we're born with absolutely bigger brains than chimp newborns are born with. So it seems to be that there is so much brain tissue a mother can grow in pregnancy. And then life figures out a way to grow the rest of it outside of her. And the bigger brain you have, the more you're going to grow outside of the mother rather than inside of the mother. At least among these well-known close relatives of us, that seems to be the way it goes. If you flip the perspective or think about it differently, that doesn't seem like we're being born early. If we're born with an absolutely bigger brain at birth than a chimp, it does sound painful. If you've ever seen a chimp give birth on YouTube, you can see this. It's wonderful. It doesn't look that hard. The chimpanzee neonate is so small compared to the size of the chimpanzee birth canal, especially compared to the tight fit of the human neonate. So it's just not fair. Evolution's not fair. And it's not enough of a reason to make these assumptions that we should be born with the same percentage of brain as a completely different organism with a completely different brain size. And that leads to this assumption that we're born early, which maybe someday somebody will come up with a clever way to demonstrate that, in fact, we are born early and we should have a longer gestation. But as of now, there is no evidence for this. It seems like we actually have longer gestations than we should. We give birth to huge-brained, huge-bodied, fat, awesome babies. And they're not underdeveloped. And they're not fetuses, as like some of these popular takes suggest, that we should be treating our newborns like fetuses because that's what they really want to be. Maybe that's a nice way to treat them, but the evolutionary justification isn't there.
So if our fat, awesome babies are just right, but barely fit through the birth canal, what's going on? If evolution is about survival and reproduction, is the mother's pelvis to blame for childbirth being difficult and even sometimes deadly? The next part of the obstetrical dilemma hypothesis that Holly wanted to unravel is the idea that upright walking was the thing that made it so the birth canal couldn't get any wider.
Because if it did, women couldn't walk, or it would just ruin bipedalism. And the evidence is women have wider hips than men, and they're already so bad at sports. And so this coming from a 1950s and before, perspective in science, okay. But that it held on for so long. And I'm not here to tell you that it's not true that women on average don't have wider dimensions of the birth canal than men in their pelvis. Because those things, those are realities. There are differences on average. There are patterns. But they cloud, I think, our judgment here with the obstetrical dilemma.
This turned out to be a tricky thing to investigate. Are wider hips actually less efficient at walking than narrower ones? Are differences in athletic performance truly down to differences in the anatomy of the bony pelvis? To investigate the part of the hypothesis that deals with walking and locomotion, Holly collaborated with another researcher who was looking into the ideas behind the obstetrical dilemma.
Yeah, no, it's my pleasure. Thanks for reaching out.
This is Leakey Foundation grantee Dr. Anna Warrener.
I'm a biological anthropologist at CU Denver, and I study human biomechanics, and my focus has been particularly looking at how the pelvis influences walking and running.
As a PhD student, Anna learned that no one had actually tested the biomechanical part of Sherwood Washburn's description of the obstetrical dilemma, that paragraph of his in Scientific American.
Laying out this progression of things from bipedalism to big brains to childbirth, and then how he considered this basically the foundation of the whole sort of social construct of human life. But he's not very specific about any of it beyond like bipedalism and big brains. And it goes on to say something like the slow moving mother carrying the infant. And that's all he says about maternal locomotion in this whole paragraph. He doesn't say anything else other than the slow moving mother. And so how we interpreted that to be like less efficient, that probably is a whole other story. But so slow moving mom has greater maternal responsibility. Therefore, she has to be provisioned by the male hunter. And that provisioning and the capacity of the male as hunter and traveler reinforces this idea that bipedalism then is compromised in females. So it's like this whole, and he actually says something to the effect of it imposed a fundamental social structure on humanity. That's like a huge claim from pelvic size, you know what I mean? And I think it's worth thinking about why we took that model and accepted that model without actually doing the groundwork of detailing the specifics. How would the mechanics work? What do we know about pelvic variation related to the success of childbirth, which I think is still an unknown question. There's all kinds of bits and pieces that need to be filled in.
To check out the locomotor piece of the puzzle, Anna wanted to see if she could measure how the width of the pelvis impacts the efficiency of human locomotion. She recruited a bunch of recreational runners, men and women, and put them on a treadmill in the lab.
And we collected data on their walking and running kinematics and their oxygen consumption while they did that.
She also did MRIs of the subjects' lower bodies in order to see and measure their anatomy from the waist down, inside and out.
And being able to get those internal diameters was really important because then we could compare aspects of the pelvis that are related to locomotion, like biacetabular width, with the aspects of the pelvis that are thought to be related to birth, the internal diameters of the birth canal. So all of that data together then ended up being a pretty useful and powerful tool to help test the biomechanics of how the model was thought to work.
She took all that data with her to her postdoc position at Harvard, where she collaborated with another Leakey Foundation grantee named Christy Luton to further test the idea that a wider pelvis would mean you have to work harder to keep your pelvis level when you walk and run, making it so women are less efficient at getting around.
So the hip abductor muscles, which are the important muscles for stabilizing your pelvis while you walk and run, were thought to be at a worse mechanical advantage if you had a wider pelvis. And if your muscles have to contract harder and work harder, that's thought to then translate into an increase in metabolic cost. And so that was the model that had been defining this idea of why a wide pelvis would be disadvantageous for locomotion. And so that's what we tested. And we really did test it in terms of pelvic width and not males and females, because we wanted to look at this as a continuous variable, because obviously there's always overlap, right, between males and females in terms of physical characteristics, even if on average there's difference. So we looked at, does pelvic width influence hip abductor function? And how does that then impact cost?
What they found is that pelvic width alone is not a good predictor of movement efficiency. And in fact, women are not measurably less efficient at walking and running.
And the reason for that is because walking and running is a dynamic movement. And when you step on the ground, it's not just your hip abductors firing to create a ground reaction force, to create a force that helps keep your body center of mass stable.
Taking a step is like a chain reaction involving your feet, your legs, your thighs, and your hips.
And at least in part because of that, pelvic width ends up just not being a very good predictor of what is going on with your hip abductor muscles. It doesn't mean that locomotion has no role in pelvic shape in humans, because it very clearly does, particularly related to bipedalism. And it doesn't mean that obstetrics has no role in pelvic shape either. It just means that we can ask questions beyond locomotion and obstetrics. And we can consider pelvic shape as a result of multiple factors and not just this headbutting of locomotion and childbirth, without the strength of data that I feel would be required to really demonstrate that the obstetrical dilemma work was true. My locomotor data demonstrates that at least the way we've previously thought about how pelvic width relates to locomotion isn't true. Now, that doesn't mean there can be some other argument for why pelvic width might be quote unquote negative for locomotion, but it's not cost.
Added to that, new studies show that bony pelvic anatomy and birth canal shape and size varies around the world, not just between males and females, but geographically. there's no evidence that these differences make people worse at being bipedal. And research by Leakey Foundation grantee Kara Wall-Scheffler shows that women are in no way at a disadvantage when walking, especially when carrying things.
The more questions people ask with different methods and different approaches and different assumptions and fewer assumptions and different lived experiences like these women, I think they're coming up with really important insights, and they're enabling us to see, okay, it's a lot messier than like this simple, straightforward, totally logical scientific story would have it.
Here's Holly Dunsworth again.
It seemed so logical. It was totally legitimate. But over time, with all the science that's piled up, we know so many pieces of this obstetrical dilemma are just weak, bad, untestable in some cases, or irrelevant. It makes the whole idea a problem, even though, yes, we have big brains. Yes, we are bipedal and our pelvis is unique. Yes, evolution is true and real. Yes, childbirth for many people is difficult. And yes, babies seem really helpless and useless. But the story just doesn't hold up.
If this isn't the story, though, what is? If the obstetrical dilemma holds that we're born when we're born because of our hips, because of our pelvis, if it's not that, then what is it?
So I learned very early on that I can't just go out there challenging the obstetrical dilemma without another idea. And that's really interesting part of scientific culture. And I don't know if it's great, but it is the way it is. To challenge something, you have to find a replacement, and you have to offer that. And I resisted that at first, just on principle, because it should be enough to say, but wait, and not have to have all the answers as a consequence. But that is holding someone to very high standards. Then you don't get to say, but wait, unless you have a better idea or a legitimate or an alternative idea. So what made a lot of sense, because I was in that literature very, very early on with the life history variables, what made a lot of sense was I'm looking at all these like mammal-wide studies. It looks like maternal body mass. Maternal body mass is a great predictor of fetal size and gestation length across placental mammals. And so that would mean like something about metabolic rate, which scales not perfectly. And the more we learn, there are exceptions. But, metabolic rate and body mass in placental mammals that's correlated. And, maybe something about maternal body mass is going to predict human gestation length and human fetal growth and fetal size. And that's not a scandalous idea.
So Holly and her colleagues put this idea out there, and an idea that another scientist, Peter Ellison, had been looking at, which was about how labor seems to be triggered when a mother can't make any additional calories to fill the needs of the baby.
He'd already been thinking about that and publishing on that. And we co-opted his idea about how that whole process ends by suggesting, okay, there's this limit. We know a lot about these details in humans. Here's what they look like in humans. Here's a human model for what we're hypothesizing works across primates and across placental mammals. And we called it the egg hypothesis, because not only can you not say, but wait, without giving a better or just some sort of legitimate idea, but you also have to name it so that people can talk about it. That was the advice I was given. And I wanted to name it ham and egg. Humans are mammals. And then energetics of gestation, length, and growth. But ham and egg is cheesy. So just the egg hypothesis, which is adorable.
The egg hypothesis says that about 5 months into a pregnancy, the mother's resting metabolic rate doubles compared to her pre-pregnancy basal metabolic rate.
And then she's sustaining that constantly day after day while the fetus is growing at a really rapid rate. And a human fetus has a big brain. So it's just like eating her up. And she is just running high. And she doesn't get any higher. And that fetus continues to grow and grow and grow and grow. And all that fetus wants to do is grow.
And when the mom can't give any more energy to gestation and fetal growth, labor is triggered, the baby is born, and it can continue to grow.
which is all it wants to do. And then during lactation, with that newborn, that mother's metabolism doesn't increase. She's at a ceiling, we think. And we think that we can find similar patterns, similar limits across primates and placental mammals.
In this scenario, the pelvis has adapted to the size of the fetal brain, not the other way around. Holly and her collaborators are testing the egg hypothesis in studies on metabolism in pregnant and nursing marmosets. And she and other researchers like Anna Warner are continuing to ask questions about the complexities of human reproduction and the impact of the evolutionary stories we tell about our bodies.
I don't have any evidence that the obstetrical dilemma has contributed to how we give birth now. I don't have any evidence that it's contributed to hospital C-section rates. I don't have any evidence that it's contributed to how women think about their birth plan or not, or what women tolerate or not. Or I don't know. I actually don't know any of that, and I'd love to know that. But then again, on some level, we have to believe it has mattered, because in this business, we believe that knowledge matters and has an impact on our behavior and our culture, especially knowledge like the obstetrical dilemma, which has featured prominently in human evolution discussions, in human evolution courses, and in anatomy courses in medical schools forever. Not forever, maybe 70 years. I can't help but think if it's already made it out to things like The Happiest Baby, that Harvey Karp, I'm not sure what it is, lifestyle choice. I'm not sure what that is, where you buy his books and you watch the videos and you treat your child like a fetus. It made it out to him, and it's peppered throughout so much of the popular spin on human evolution. It has to have influenced childbirth and how it's done and how we experience it. But I just don't know. But I can't help but think, if you think that women's bodies, that evolution, because of evolution, women's pelvises are compromised, and that we have this dilemma, and women's bodies aren't built optimally, really. If you have any of that creeping in, how much of that contributes to you even just a little bit thinking culture's got to fix this, medicine's got to fix this, evolution got us so far, and now medicine's got to fix this? There are some stories we tell about the body that if we change them, that we would be better to each other. And this is one of those.
Many thanks to Dr. Holly Dunsworth and Dr. Anna Warner for sharing their work. You can learn more about them on their websites. The links are in your show notes. I've also added links to research papers, videos, and more. We've been getting some amazing questions for our audience question episode. Please keep them coming. Ask anything you want to know about human evolution, and we'll find someone to answer your question. We'd also love some questions from kids. So leave a voice message at speakpipe.com/origin stories or call our voicemail line at 707-788-8582. Origin Stories is a project of the Leakey Foundation, a nonprofit dedicated to funding human origins research and sharing discoveries. You can support this show and the science we talk about by making a donation to the Leakey Foundation today. All donations toward the podcast will be quadruple matched. We're trying to raise $1,500 by the end of August to meet a quadruple matching challenge from Jeannie Newman and the Ann and Gordon Getty Foundation. Every dollar you give to support the show will be multiplied times 4. Visit leakeyfoundation.org/donate and leave a note in the notes section to let us know your donation is for the podcast. I want to especially thank Lynn and Larry Shaffron for sponsoring today's episode of Origin Stories. We're so grateful for their support of the Leakey Foundation and our educational programs. This episode was produced by me, Meredith Johnson. Our editor is Audrey Quinn. Theme music by Henry Nagel, and additional music by Blue Dot Sessions and Lee Rosevere. As always, thanks for listening.